Rwanda Basic Education Board Multimedia Production Studio is on a mission to transform education through technology, with a vision to
improve themselves and support each other's growth. We aim to bring this program to all schools.
To achieve this, the studio focuses on developing high-quality multimedia learning materials, supporting cost-effective digitization, improving capacity, and ensuring learning continuity. By expanding broadcast channels and streamlining production, it aims to make education more efficient and widely available. The studio adds significant value by reducing costs, increasing in-house production capacity, and ensuring rapid content delivery through social media, television, and radio. From multimedia learning materials and live science experiments to edutainment programs and digital textbooks, the studio embraces a diverse range of content. Its delivery methods include pre-recorded and live-streamed programs, talk shows, documentaries, and sign language videos, ensuring inclusivity and engagement for all learners. Through innovation and technology, the Rwanda Basic Education Board is shaping the future of education, making learning more dynamic, interactive, and accessible.
Good afternoon, class. How are you? We're fine. Yes. Also, I'm fine. Yes. So today we have a course. We know it is a time for mathematics. Now we are going to see how we can apply our Thakos theorems in our real life. Of course, it is a mathematics. Then I want you to see this picture. Then you tell me what you're observing on it. Someone? You?
In this picture, we're observing people who are riding bikes.
Oh, good. That's why we're going to see how we can rate. Now, our mathematics is what? The secret. Now, so we have a video. I want you to the same to me, to watch the video. Then we answer the question, which will be the next. So, okay, are we together?
Yes.
Okay, then. So, what do you see on this video? Yes.
The wheel is rolling on the tracks, moving from one point to another, and what I have observed is that from one point to another, it is completing a full revolution.
Good, thanks. Then I want you to answer the other questions. So then from the video, what is the revolution of the wheel? Yes, Anael? Is it okay? Is it matching?
Yes.
Sure?
Yes.
Okay, good. So then, so it is clear the revolution of the wheel is equal to the circumference of the circle.
Yes.
So next, it is another question, of course, but we see the formula we can use to find the circumference, which is also the what? The circumference of the wheel. Yes. Good, thanks. So who can read this next question? You?
Question number 1B. What is the relationship between the circumference of the wheel
Yes.
and the distance from point A to B?
Yeah, who can answer the question? Yes.
The circumference of the wheel and the distance from point A to B, they are equal because the circumference of the wheel is equal to the distance it has moved.
Okay, is it okay?
Yes.
Yes.
Okay, it is okay. Now, let us continue, and it is clear they are equal. If you remember, the distance from A to B, it is the circumference. Okay? Now, next question, it is about also our video. Who can read the question? You?
How do we find the total distance of the laps of the cyclist?
Yes. Who can answer? Yes?
We are going to find the distance. The formula is 2 pi r, when r is the radius times n. N is the number of laps.
Number of laps.
Yes.
Then what is R?
It's the radius.
Is the radius.
Yes.
Okay. Now, can you come and write, who can come to write the formula of the circumference of the wheel? Yes? Yes, come. Circumference of the wheel. Of course, and the total of laps. So then I want you to use this one. Yes, I want you to write. Total distance, of course. This is the formula. Is it okay?
Yes.
So if it is okay, now next is about also some examples on this topic. So what we see, this is the correct answer. This is the formula, and she's saying that n is the number of laps, and r it is the radius. Okay?
Yes.
So now have an activity relating to this topic, but I want you to see the picture first. Then you tell me what you're observing on the photo. Can tell me someone? Yes?
It's a cyclist cycling around, I think, Rompwe.
Okay, another one? Yes?
In the image, we're seeing a cyclist. We're seeing a cyclist who is moving around a roundabout.
Okay, now, question related to this picture, now it is this. So I want you to sit in a group, then you do our question. If you have a question, you can ask, no problem. I'm here to help you.
Cyclist radius is equal to 15 meters. We're completing half circle. That means, okay, if we have the distance, it's 2 pi r. If it's half, it's divided by 2. The distance is equal to d. 2 times 3.14 times 15 over 2, which is equal to 3.14 times 15.
If you are done, you can tell me, then I can come to help you to see if it is correct.
7.1.
Okay, 47.1.
Yes.
Okay, is it 47.1?
Yes.
Okay, let us see the correct answer. Now, so the real answer, which is correct, I want you to see if it is matching
Yes.
with yours. So now, this is the circumference, and this is the half, and it is 15 pi.
Yes.
And no, pi is equal to, who can tell us? Yes. 22 over 7. Is it okay?
Yes.
So we can use 22 over 7 or? Yes?
You can also use 3.14.
3.14.
Yes.
Good. So we have another activity related to our topic. So I want you to see our picture. Then you tell us what you're observing in the photo. Yes? Microphone?
As you can see, the radius of the first flow is bigger than the last one. with a difference of 20 centimeters.
Why? Huh?
As the first wheel, as you can see, it has 40 centimeters, and the last one has 20 centimeters.
Okay.
That makes it bigger.
Good. Thanks. So our activity now is related to this question. Okay? So then who can read the question? Yes?
Two cyclists are riding a bicycle of wheel radius 20 centimeter and 40 centimeters. If both wheels rotate 100 times, which wheel travels further?
Okay, good. The same. The group, let us first do it. Okay?
Second,
I around 20 centimeters.
going to the distance for the first cyclist.
Times 22 times 20
Then
divided by 7.
Yes.
then times n.
12.57.
Can you ask any question you have in your group?
7
Yes?
Can you show us the number of the number of laps?
The number of laps are here. You have, if it is 10 times, it is the number of laps.
Okay.
Good. Finish?
Yes.
If you're done, tell me. Then I can come to see if it is okay. So one group to present, it is time. So, yes, come on blackboard. So you remember the question? I think you have it. So then I want you to answer the question by using
As we have seen, the circumference is equals to 2 times radius. We are also going to multiply them, which represents the number of laps that the cyclist made. 2 times pi, which is 3.14, times the radius, which is 20, times 100.
Okay, calculator please.
125.
So,
We also have the second cyclist whose radius is
okay.
40 centimeters.
Then I want you to conclude.
So, in conclusion, the radius is directly proportional to the circumference, which means that the bigger the radius of the wheel, the larger the circumference, hence the greater distance covered than the other one, than this one with a small radius of the wheel.
Is it the machine we are finding?
Yes.
Good. So then, yes, thanks. So then we can continue. So if it is correct, this is the correct answer, and you can see now it is matching. Okay? So you have the first distance, the radius 20, and you have the second distance before as 40 and as radius, and you can see the conclusion. I can say it is matching.
Yes.
Okay, so if you are together, so I want to ask you one question. So I want you to relate now this, of course. So I want you to relate this question with the events that Rwanda is posting today. Okay, who can tell us? Yes. Yes, tell us please. No problem.
As you have seen, in the last video,
Yes.
the bigger the circumference of a wheel, the more it travels further. So the advice I can give to the cyclists is to use the wheels of the same size in order to reduce accidents and irregularities in the road.
Another one? Yes?
I think the cyclists should use wheels of the same size to reduce the unfairness in the competition, so we can be all fair to each other.
Another one? Another one? Yes.
I think that option is very important in the races of the cyclists because they have to cover the same distance with the same laps.
So,
If they have
claps.
same size
So, okay, now it is correct. So, thank you for your answers. Now let us continue, and you can see now it is okay. Okay? Of course, all cyclists must have the same size of what? Of their wheels. Okay? Now, good. So, we have another activity. Then I want you to see this video. But it's not a video, you can see it is a picture. What are you observing on it? Yes?
As we see on the image, the cyclist is cycling around, and as it is written, the cyclist completes 3 full laps. So I think they will be asking like the distance or the circumference of the wheels that he's using.
Good, thanks. Who can read this question? Yes?
A loop circuit in Kigali is a perfect circle with a radius.
Voice, please.
A loop circuit in Kigali is a perfect circle with a radius of 400 meters. Cyclists complete 3 full laps. What total distance is covered?
Okay, in our groups, of course. Our respective group. And the question.
A loop circuit in Kigali is a perfect circle.
Distance is equal to the circumference times number of laps.
It's 2 times 500 of 10 moles.
Okay.
3. 2 times 3.1 times 500 times 3.
Yes.
9,200.
So, this is our question. Feel free to ask in your groups.
Meters.
So, remember it is in 5 minutes. Anyone? Okay, good. So, I want one group can present. Can make correction on blackboards. Please, one group. You see, we have 4 groups, yes? So, your microphone.
As the question asks, there is a loop circuit where the
So you can bring
the
your
radius,
your findings.
is equal to 500 meters. They're asking us the number of laps is 3.
Yes.
They're asking us the distance which will cover these 3 full laps.
Okay.
So we're going to first calculate the circumference of the wheel, where you will get pi times 2 times r, or 2 pi r. Then you will get 2 times, you will get an answer of 3,140 meters. Remember the meters because the radius they gave us is in meters. But they did not ask only for 1 lap, so they asked for 3 laps. Here you're going to multiply by 3 to get the full distance. Then you get that the answer is 9,420 meters.
Okay. So you can see he's using a pi which is equal to 3.14.
Yes.
Okay, good. Thanks. Can you clap for him? Okay, good. So now Next is about, of course, the correct answer. I want you to see if it is matching with mine. Okay? So this is the real answer. You know the radius equal to 500, and you know the formula, which is C, and there you have 1000 pi. So then by multiplying by 3 laps, you have 3000. Now, okay, so I want you to see again this picture. What are you observing on it? What are you observing on it? Yes?
I'm seeing a person in the center and the cyclists around him, and I'm seeing the angle of 60 and an arc in that side.
Good. So then, who can read this question, which is related to the picture? Yes.
This spectator stands at the center of a circular viewing platform with a radius of 20 meters. Cyclist passes around the edge, covering 60 degrees high. The sub-question A says that what is the arc length the cyclist travel?
Then number B. Question number B. Who can read question number B? Yes. What voice, please?
Question number B says that if a team of 5 cyclists pass through this arc, each space 2 seconds apart, how long does it take for all of them to pass?
Good. So then, in our respective groups, can do it first before being on blackboard. Finished? What do you see? You are done. Okay. So remember, have number A and number B. Yes. We do all. Now A and B. Okay. Then number B. Okay. Yes. Yes. Okay. Okay. Okay, good. So thank you. So who can come to present the group? So you know you have 4 groups. Someone? No one? Good. Yes, come. So remember to bring your events. Okay? So then use a blackboard. Yes? Please, I want you to follow. Okay? Good? Yes, thanks.
Okay, thank you. Okay, as we saw, they asked us to look for the arc
Raise
length.
your voice, please.
They asked us to look for the arc length, and we were given radius. Can I see the question?
Radius is there.
Radius is equal to
20 centimeters.
20 centimeters.
Yes.
And we were given the angle
Theta.
of 60 degrees.
Yes.
And they asked us to look for the arc length.
Then arc length.
And as we saw, our picture was like the person was standing between. I think I should draw so that I explain to you well. Okay, we are having 60 degrees here, and they are telling us to look for this area, arc length.
Okay.
So as we learned, arc length is equal to angle
theta as the angle given over 360 degrees times 2 pi r.
Okay.
So the angle given is 60 degrees divided by 360 degrees times 2. And as we know, pi is equal to 22 over 7.
Yes.
Times the radius given is
60.
Is it 20?
The radius.
20 meters, I think.
Okay. Then, okay.
So we are going to calculate. This goes with this. By 6, we are having, by 2, we are having here 3. By 2, it's 18.
See, I want you to see if it is correct. And you also use your calculator to calculate if it is okay. So check please. Then find the correct answer.
The answer is equal to 20.9 meters. Because they are asking us to look for the length.
Is it A or B?
Question A.
It is A. No. A, is it okay? Yes. So who can do number B? Yes, come. Yes, thanks. Number B. Here, please. Okay.
On number B, as the question says, there are 5 secrets.
Yes.
Given data, let the secrets be A. And the time BT.
Okay.
In the problem, they said for every 2 seconds, one secret started the race.
Yes.
So to calculate, I think D is equal to N times T.
Okay.
Where N is equal to 5 and T is equal to 2. Then we get 10.
10. Clap, please. Okay? But I want you first to check if it is correct. Is it okay? No. So, who can make what? Correct on it. Okay? Yes, come. Okay. Make correction? Yes. Of course, here. Then we see the correct answer.
As he said, the cyclist BN and the time BT. But for the first cyclist will be removed because the first 2 seconds for him didn't count. He was removed for the first 2 seconds for him didn't count. So it was between the second, third, and fourth. So we are taking this number he used, D, will be equal to N minus 1 minus the first cyclist because the 2 seconds didn't matter times T.
Okay.
So the T which represents the 2 seconds, which is the space between the two. So N, as he said, there were 5 cyclists minus 1 times T which was represented by 2, which equals this one adds up to 4 times 2, which equals to 8 seconds.
Good. Can you clap for her? Yes. Thank you all. Okay. Now, so, and I can see also it is correct. So, but let us come to our topic again. So, that is here. Okay. So, and see it is correct. You have radius, you have theta, and you have arc length. The formula, which is okay, and which is matching with yours, have arc length total, which is 20.9, and you have also number B, this was number A. Can I say expression? It is okay.
Yes.
Okay. Now, so then after this topic, so I want to ask you, okay? I think you remember the conclusion you can make Now, how can we rate now our topic with the event Rwanda is hosting? Yes, Anael?
To conclude, I would say that mathematics is important because it helps us in teamwork, discipline, endurance, and strategy, which are also key values that are used in a race and cyclism.
Okay, okay, good. Thanks. Another one? Yes?
Thank you. Thank you. Through cycling, we can explore concepts like, as we have been looking at, we are looking about the distance, circumference, area, something like that. So as we see, cycling helps us in solving problems, like if we are looking for speed of the distance covered by a cyclist, as even if we are looking for the revolution, okay, the circle, okay, the times he has completed a circle. Another thing, it helps us in looking for the time taken during the cycling, because they always give them time, so we always happen to solve problems about time, because we always have to count the time a cyclist has taken. Thank you.
Okay, thanks. Another one? Yes?
I think this championship, which has a relationship with the math we have been talking about, highlights Rwanda as a rising international hub for sports by promoting tourism, where you find that tourists have come a long way from other countries to come to Rwanda to watch this championship. It creates unity between the countries, the people, or the citizens that they live together, where you find that even in the teams, teammates work together to achieve one goal, which is the same, to win the championship. And we also have the national pride, which it's the first time that this championship has ever been hosted in the whole of Africa, and most importantly, it has come here in our loving country, which is Rwanda. Thank you.
Another idea? Yes?
Just to see what we learn in class is really used in real life.
Okay,
Thank you.
Thank you. Oh, thank you. Claps. Okay. So, thank you all. This is the end of our lesson. And thank you for your participation. That's okay. So next time, we shall meet by seeing another topic. Thank you.
Thank you.
Thank you. I'm here by the names of Shimna Lina Perla from Flower Girls School, Gisozi, studying in Senior 3. I'm here to recite a poem entitled The Road to Kigali. Each morning I rise with the sun so bright, my clean school clothes, my dreams held tight. From faraway halls I race to train, through roads full of rain and wind. I see the peaks, I feel the sky, I chase the wind as the eagles fly. Though roads are rough and my shoes are torn, a champion's heart in me is born. One day I'll race in Kigali town with cheering sounds all around. In Rwanda, hills so green and high, I ride with hope beneath the sky. Kigali 2025, a dream of life, a world of wheels and a dream to find. Someday I'll hear the crowds and cheer, and with hope that I'll be riding there. From village roads to valleys low, pedal by pedal, slow by slow, my bike and I, we never stop. We climb each hill, we reach the top. They say the world will come to see as Kigali shines in victory and pride. The UCI will crown the best, and with hope, I'll be among the rest. So every morning, good or harsh, I train alone, but never rush, because the road though long and steep, is paved with dreams I vow to keep. Thank you.
abakurambere b'intwari bitanze batizigama baraguhanga uva mu bukombe utsinda ubukoroni n'amatsi ibihugu byayogoje Afurika yose none uraganje mu bwigenge tubikomeye uko turi twese.
Poem. The road to Kigali. With a bike too big for my size, wheels that are wobbly and large, a seat that sits high, no helmet, no shoes, just feet full of dreams. A dusty road I ride with cows and goats on my side, waving at aunties with baskets in arms. They laugh and say, "Hey, you're riding where?" I shout, "To Kigali," with dreams alive. I've seen the pros on TV screens in shiny kits and big race scenes. They ride on roads so smooth and wide with bikes that fly so fast and high. I heard of a place full of hills that twist and bend, in a country so popular with beauty so real to conceal. Kigali, Rwanda, Africa, a cyclist dream. I dream of crowds that cheer and shout with a roar so loud that it shakes my soul like thunder pushing me towards my goal. My mama says train with heart, so I train every day and do my part. Up dusty paths with no applause, just crickets cheering and barking dogs. Sometimes I fall, sometimes I try. Sometimes I fall, sometimes I cry, but every fall just makes me try. For Kigali calls like a distant drum, and I ride faster, knowing I'll come. I see myself in a jersey bold, my flag on my back, my story told. Standing proud with legs like steel and tears of joy, so true to hold. I don't have much or a lot, but I'm sure that I do have this. A dream that burns hot inside with my friends, my family by my side. Oh, I can't forget my dad's advice. He always says, if anyone can walk, anyone can ride. And I know, my child, one day you'll make it there. And so I ride today, I'll ride tomorrow. Through sweat and laughter, hope and sorrow. Because I know that one day, just one day, I'll make it there. And if I make it there, you see that dreams grow strong on broken knees. From village dust to Kigali's right, this rider's heart is set for flight.